math has been driving you crazy, or if you're finally admitting you're lazy, and your test grades have been dropping, it's time to get your arrows popping. Hello, how's everybody doing? This is Mr. Witt with Fort Bend Tutoring, and today we will continue our final exam reviews, this time with geometry. That's right, the end of course, second semester, final exam review for geometry with Fort Bend Tutoring. That's what's going on, ladies and gentlemen. Today we have geometry. And as a reminder, go ahead and subscribe to Fort Bend Tutoring. Share the screen with the people that you love, with the people that you know out there, with the people that's been getting on your nerves because they've been asking you geometry questions. You didn't have the answer to them, but Mr. Witt and Fort Bend Tutoring has all of the answers for you. That's right. Chanel in the house with the witnesses. What's going on? And yes, you finally made it. Chanel Simone is in the house, guys. We got Mr. Monkey in the house. Woohoo, says Mr. Monkey. Gotta show some love to him. And guys, we're going to be going through some geometry problems, getting you prepared for your final exam reviews. Admittedly, I don't have a huge love for geometry, but we got a big love for you guys. So that's why we're going to go through this geometry final exam review and get you guys prepared. Amen, amen. And let's start with problem number one. Here we go. Problem number one. Let's go ahead and get it in view. Get it in view, Mr. Witt. Come on. There you go. All right, guys. It says the geometric mean of 3 and 12 is, we have choices 2, 4, 6, and 8. And in order to find the geometric mean between two values, you'll use the following formula, guys. Let me go ahead and get my ink here to black, and we'll set it up as A over X equals X over B. All right, so this is going to be our setup right here. And from this, what's going on, Charmaine? What we'll do is we'll replace the values of A with our 3 value, while we'll be replacing the value of B with 12. There it is. So go ahead and plug that into this formula for the geometric mean and then solve for X. That's how you go about finding the geometric mean of two values. So we'll rewrite this as 3 over X equals X over 12, and then now what's going on, Raul? Raul already says that we have 6 as an answer. Let's go ahead and verify that. We're going to be cross multiplying here using that extremes means method. In other words, getting those arrows popping to end up with 36 equals to X squared, guys. Take the square root of both sides, and of course we want the positive root here as we're doing this process. So X equals 6, and as Raul said, we have our answer here. And ladies and gentlemen, we got a red box around it, so this is C as our result. That's right, the answer choice is C. Let's go ahead and put a red box around that as well. That's right, Raul, we're gonna red box it for problem number one with the geometric mean, guys. So you need to know that the formula for the geometric mean right here is this proportion: A over X equals X over B. Amen, amen. Oh yeah, we starting off to a good start for the geometry, if I can say it right, for the geometry final exam review. And here we have problem number 2, guys. It says to find the perimeter of a square whose area is 36. So all right, let's go ahead and check this out. Once again, we have some multiple choice here. We have choices of 6, 12, 24, and 36. If we have a square, ladies and gentlemen, let's go ahead and draw out the square here. All right, we know we got 90-degree angles everywhere. We know that all the sides are congruent to one another, absolutely. And we know that the formula for the area of a square is side squared. And in this case, the area equals to, can I get it right? It equals to 36. There we go. So if the area is 36, let's go ahead and solve for our side. So it would be side squared equals to 36. We would have to take the square root of both sides just to find out the length of the side here, guys. And we would find out the length of the side is 6. So if the length of the side is 6, that means that each one of these sides here has to have a value of 6. And so the perimeter is the distance around this object. The perimeter for a square, guys, is 4 times the side. So if you were to multiply that out, all right, let's go ahead, because There we go. We had to keep it in view. We would have 4 times 6, and that gives us a value of 24. And once again, Raul is correct. Make sure, Raul, that we had a unit of measurement, even though they didn't have it in our answer choices. It would be our units squared. There we go. Units squared. So our answer choice here is C. Let's go ahead and put a red box around C. Hopefully not all the answer choices are C. We don't want it to seem like it was rigged. That's right. To where all of the answer choices are going to be C today. So that's problem number 2. There you go. Find the perimeter of a square whose area is 36. Done and done. Let's go ahead and continue on with our geometry. Final exam review from Fort Bend Tutoring. We have problem number 3, guys. It says for the triangle MNO, the length of NO is what? We have to figure this out. Now, admittedly, we have a right triangle in our diagram here. We know this because this symbol here tells us that angle N is a 90-degree angle. So because of that, you're dealing with a 30, 60, 90-degree triangle. So let's go ahead and mark that this angle here must be 60 degrees because the interior angles, the sum of the interior angles of a triangle, guys, has to equal 180 degrees. What's going on, Marcos? Hello from Brazil in the house. Thank you for joining us today, Marcos. And then just to give you guys some insight here, when you're dealing with a 30, 60, 90 triangle, we have a ratio that is going to be played out. For instance, the ratio is 1 square root of 3 and 2 as far as the ratio is concerned. And as far as setting up equations is concerned, if your value of 30 degrees, the side length of the side opposite the 30-degree angle, if that value is x, then the 60-degree side, the side opposite the 60-degree angle, if I can say it right, would be x times the square root of 3, and then the side length opposite the 90-degree angle would be 2x. All right, so you can use this as a reference when you're dealing with the special right triangles, the 30, 60, 90 right triangles. There we got Antoinette, all right, from Jersey. Edwin is coming in from Chicago. How's it going there, Edwin? Good to see you guys. And to solve for the side length NO, that's going to be the side length that is going to be right here. So what they've given us so far is they've told us that 2x equals, okay, this side length opposite the 90-degree angle, that would be a value of 10. So if I'm solving for x according to my ratios here, I could divide both sides by 2 to figure out that the value of x would be 5. However, the length of NO in reference to this 30, 60, 90 setup I have here would be x times the square root of 3. Okay, so in other words, all I have to do, let's go ahead and get that in view for you guys. There you go. So all I would have to do is multiply 5 times the square root of 3 to get my answer. So this answer here, because the x square root of 3 is what I need, if I know that my value of x is 5, the answer must be 5 times the square root of 3. And you can figure it out just like that using the 30, 60, 90 ratios, which you have right here before you. So because I knew that I needed the side length for NO, which was opposite the 60-degree angle, that relationship in reference to the 90-degree side, all right, would be x times the square root of 3 if this length is 2x. And that's it. We got a red box coming. That's exactly what we have coming, just like that. Yeah. So that's using your 30, 60, 90-degree rules for special triangles. There you go. Yeah, that's it. That's it. And notice all they had to give us was basically an angle there, knowing that we had a right triangle as well as one of the sides to figure out the rest. So this would not be a case where we could use the Pythagorean theorem in order to solve this. All right. So knowing your relationships for your special right triangles is important for success in a problem like this, guys. All right, let's move on to our next problem here, which is problem number 4. Let's check it out. It says a wheelchair ramp has a slope of 1/10. If its rise is 5.5 feet, what is its run? All right, well, talking about that slope value, that M value, when you're dealing with the slope, we can define that as the rise or the change in the y values divided by the run, aka the change in the x values. All right, so this is what they're referring to. Okay, there we go. The rise divided by the run. So we're given a slope of 1/10, right? And we want to know if your rise in this ratio is 1, what would be the run if the rise is 5.5? Okay, so you could set it up this way. Yeah, just like that. All right. In other words, you could rewrite it if you wanted to as 1/10 is equivalent to 5 5/10 divided by x. You could do that. And then cross multiplying. All right, we would have x times 1 is x, and then 10 times 5 5/10 gives you 55, guys. So therefore, if the numerator, if the rise is 5.5, then that means that the run must be 55. And that's it. And we just use proportions to solve that. Yeah, we just use proportions because they're giving us a standard, in this case the 1/10, and they're saying that that ratio must be equivalent. That set of the slope has to be 1/10, given the fact that the numerator, the rise, would be 5.5. So we just had to figure out what that denominator was, and we just used the extremes means method in order to solve that, aka we cross multiplied, ladies and gentlemen. That's exactly what happened. Oh yeah, that's exactly what happened. And so we're going to be moving on because you have more problems to answer. This is the final exam review. We can't be dilly-dallying. Oh, no, we cannot. Problem number 5, guys. Problem number 5. It says, find the sum of the measures of the interior angles of a decagon. See, they're trying to test you here, you see. They're trying to test your knowledge of polygons here and their names. So we know a 3-sided polygon is a triangle, right? What's going on, Fabiola? We know that a 4-sided polygon is called a quadrilateral. We know that. But then they just ramp it all the way up to a decagon. I mean, you know, a pentagon is 5 sides, a hexagon, right? A hexagon is going to be what, 6 sides? Heptagon, 7 sides? Yeah. Octagon, 8 sides. A nonagon, 9 sides. Decagon. We have a 10-sided figure, guys. So a decagon is a 10-sided polygon. That's what we're dealing with here. All right. So the first thing, what's going on, Shailene? So the first thing we had to realize was what they were referring to when they mentioned decagon. They're talking about a 10-sided polygon. Oh, yeah. Now we'll need a formula, a way to solve the sum of the interior angles of this 10-sided polygon. Right. So the formula that you'll need here is n minus 2 times 180. Oh, yeah. See, you need this formula. Oh, you need this in your life if you're going to solve this problem correctly, where n is the number of sides of the polygon. Oh, yeah. And knowing that a decagon has 10 sides, guys, we go ahead and plug in that value of 10 into this formula and we simplify. That's exactly what I'm going to do. That is exactly what I'm doing right here. Thank you very much. So I replace my value of 10 with the n. All right. And I need to make sure that you guys know that this is not a minus sign. Oh, no. Oh, is it? Yeah, it is. Yeah, it is. It is a minus sign. That's a minus sign. What's going on, Kaylee? Kaylee's in the house. We'll have 10 minus 2 gives us 8 times 180. There we go. So we started out by recognizing, one, that a decagon was referring to a 10-sided polygon. 2, because they wanted the sum of the interior angles of the polygon, we had to use the formula n minus 2 times 180, and then we plug in our values for n and simplify. Right now, I need to multiply 180 times 8, guys, because I don't know what that is. I don't know what that is. I do not know what this value is. 8 times 0 is 0. 8 times 8 is 64. I'm gonna go ahead and carry that for 6 right there. 8 times 1 is 8 plus the 6 gives me 14. There we go. There we go, guys. There we go. We have 1,440 degrees. That is the sum of the interior angles of a decagon using the sum of the interior angles formula. Yeah, and I'm going to put a red box around this for the people, for your protection. That's right. We don't want to let that get out. We don't want to let that out of the box. We want to keep that in the box with a red box, Shailene and Fabiola. That's what we're doing here. All right, so we have problem number 5, guys, and we're moving on for problem number 6. And in problem number 6, it says to find the volume of the pyramid. Find the volume of the pyramid. And notice, guys, in this pyramid, we have, that's right, Dilshad, we had to put a red box around it. So in this one, we have a pyramid. We want to ask for the volume. We're asking for the volume. They're asking for the volume. Thank you. And we have a square base. That's right, our base is square. So what do we do with this information? Well, for one, when you're dealing with a pyramid, you need to know that the volume of a pyramid is 1/3 the area of the base times the height of the pyramid. And since our base is a square, then that means that the area of our particular base here is going to be the side squared, knowing that the side of this area is 16. There you go. All right, let's plug this in. So what we'll do is we'll say that we have 1/3. Because the area of my square base is going to be the side squared, I can say that this is going to be 16 squared here, times the height of the pyramid, which in this case will be 15. See, they're giving you some extra information in this problem, guys. See, this 17 value over here, this is referring to the slant height, which we don't need to solve this problem in this case. All right, so we just need the true height of the pyramid, which in this case is going to be 15. So that 17, you don't need it to solve this problem. No, you don't. But instead, guys, I'm going to be a little lazy in my process, and I'm going to simplify before I multiply here. I'm going to say that I have 3 going into itself once, and 3 will go into 15 5 times. I'm going to do that. Also, knowing that 16 squared is 256, pick up the sticks. I'll be multiplying that times 5. Thank you very much. And I end up multiplying the 256 times, thank you, times 5. That's exactly what I'll do. I don't know what that is. I don't know what that is. Okay. I know you guys know what that is, but I don't know what that is. We'll have 6 times 5 is 30. I'm going to go ahead and carry that 3. We got the 5 times 5 is 25. 25 plus the 3 gives me 28. Thank you. Go ahead and put that over there. Thanks. We'll have 5 times 2 is 10. 10 plus 2 is going to give me 12. So is that 1,280, guys? And that's going to be meters cubed, as our volume needs to be to the 3rd power. Okay? So how are we looking on that, guys? Can y'all verify that that is the correct answer for the volume of this pyramid? Amen, amen. That's what they wanted to know. We used the formula. The volume is going to be 1/3 the area of the base times the height for our pyramid here. And we went ahead and solved for that accordingly. And we put a red box around it because that's how we roll. That's how we roll. And that was problem number 6, ladies and gentlemen. Also, just to remind you guys that you can set up a paid online one-on-one tutorial with me, Mr. Witt. Just go ahead and go to Fort Bend Tutoring's website, which is tutormemath.net. Tutormemath.net, and set up a paid one-on-one math tutorial one-on-one with Mr. Witt. There you go. We can do it online, you know what I'm saying, with FaceTime and Skype and all that kind of stuff. We can make that happen. That's right. Well, I'm giving you my undivided attention as you so deserve. Let's look at problem number 7, guys. Problem number 7 says, what is the area of a circle whose circumference is 16 pi? Well, when we're referring to the circumference of a circle, we can use one or two equations here. The first being that the circumference is 2 pi r. Yeah. And we also need to keep in mind that since they're referring to the area of the circle, that the area of a circle is going to be pi r squared, right? So with that area being pi r squared and the circumference being 2 pi r, given the circumference of 16 pi, let's go ahead and replace that c with 16 pi here. We'll have 16 pi equals to 2 pi r. See, we're using this formula for the circumference in order to identify the radius, because we need that radius in order to solve for the area of the circle here. Okay, so plugging in the given information of 16 pi and also knowing that that formula for the circumference is 2 pi r, then we can solve for the radius by dividing both sides by 2 pi. That's what we can do. And we'll end up with a radius of 8, ladies and gentlemen. That's right. The radius is 8. So knowing that, plug that value of 8 into the equation for the area of a circle to solve for the area. So this is going to be pi times our radius is 8 squared. So this gives us a result of 64 pi. And we'll leave it in terms of pi, ladies and gentlemen, because we started out in terms of pi. Notice that they gave us our original circumference as 16 pi. So it's okay in this case, unless they otherwise state, to leave our answer in terms of pi. And don't forget, with that unit of measurement, guys, the unit of measurement for this, let's go ahead and write it properly here. It would be 64 pi, and then our unit of measurement would be the units squared. Okay, so if it's inches, it'll be inches squared. If it was going to be meters or centimeters, those would be squared. It would be square units, whatever that is. King Valdez is in the house, giving me a compliment, talking about Mr. Witt is the best. Thank you so much, King Valdez. I appreciate your support. It keeps me going. It keeps these red boxes boxing in red. I appreciate that. All right, so we have problem number 7. It's there. I mean, it's been recorded for all eternity for you to see and judge and perhaps learn from. That's problem number 7. We're moving on to the next problem. Thank you very much. We have problem number 8. It's in your face. It's all up in your face. Problem number 8, guys, says if the legs of a right triangle. You know what? Without a diagram, I'm drawing one. When they refer to these shapes, I like to draw it out so I can know visually what they're referring to. So if the first line is saying if the legs of a right triangle and I don't see a right triangle, I draw one. I draw one because you want to feed yourself with as much information as possible, okay, in order to successfully complete the problem. So especially in geometry, guys, when you're given a word problem like this and they don't give you a diagram, draw one for yourself. Give yourself the advantage of having more information for your brain to process in order to get to the correct answer. All right. That's one great tip to keep in mind. So let's continue then. It says that the measures of this right triangle are 5 and 8. And remember, they're referring to the legs. So it can't be the hypotenuse, that longest side that's opposite the right angle. It has to be the other two side lengths have to be 5 and 8. There we go. So I've labeled it accordingly. Now it says, what is the length of the hypotenuse? Well, I have 2 of 3 sides of a right triangle. What does that mean to me? That means that I'll be using the Pythagorean theorem. That's what that means. We're going to be using the Pythagorean theorem in order to solve this problem. And what is the Pythagorean theorem, you may ask? It is a squared plus b squared equals c squared, where the a and b values are the side lengths of, they're the legs of the right triangle, whereas the c value is the hypotenuse, aka the longest side of that right triangle. So plugging in our values, guys, we'll have 5 squared plus 8 squared has it equal to c squared. That's our setup. Then continuing this out, we know that 5 squared is 25. We know that 8 squared is 64. And this has to be equivalent to c squared. From here, guys, we'll go ahead and say that summing up the 25 and the 64 will end up with 89. So you have 89 equals c squared. And then from there, taking the square root of 89, that will give us our result that we're looking for. And our result, by the way, guys, is c, the hypotenuse. It must equal to the square root of 89. And this is our answer. You cannot simplify this particular radical any further. Done and done. That's it. That's it. So because we had 2 of the 3 sides of a right triangle, we went ahead and was able to solve this using the Pythagorean theorem. All right. So if we were to completely label this, we would have said that our legs were A and B here, whereas our C value must be the length of the hypotenuse, aka the longest side, aka the side opposite the 90-degree angle. All right. So that's what we're working with here, guys. And that was problem number 8. Yeah, that was problem number 8. Oh, yeah, we're just moving along. We're just moving along here. I have problem number 9. What you going to do? I got problem number 9 in the house. And it says if angle A is a right angle and the measurement of A equals to 4x plus 10 degrees, then x has to be what? Well, let's take a look at this then. So let's say that we have an angle, all right, like this. They said that angle A is a right angle. All right, so there we go. I can show that using that symbol, that angle here, and we'll label it A, that this angle has to be a 90-degree angle. Okay. They also are saying that the measurement of angle A is 4x plus 10 degrees. Okay, we can accommodate that. There we go. King Valdez says I got to go now, but I'll be watching this from the start. Bye, guys. Take care, King Valdez. Thank you for chiming in, sir. Appreciate that, King Valdez. Well, one thing we know about a right angle, guys, is that a right angle has 90 degrees. A right angle is 90 degrees. So therefore, you can set up an equation that reads 4x plus 10 must be equivalent to 90 degrees. And then in order to solve for x, we are going to solve for x by isolating the term of the variable. All right, Simone says Pythagorean theorem is the name of the problem. Now I know, cross that confusion off the list. There you go. There you go, Simone, just trying to help. You are being a witness. All right, there you go. That's just an inside joke. That's just an inside joke. Simone said that the people that Simone said that earlier, that the people that benefit from the teaching from Mr. Witt are witnesses. I thought that was extra cool, and I'm a bit jealous of Simone because I didn't think of it first. Thanks a lot, Simone. Appreciate that. You would think that after all these years, I would have come up with something as equally clever as you, but I did not. We're solving for x by isolating the term of the variable. I started out by subtracting 10 to both sides. Using the division principle of equality, we're going to be dividing both sides by 4, and then you will end up with your value of x, which is 20. 80 divided by 4 is 20, guys, and we will red box this. So that's the value that belongs in our blank at the beginning. They're looking for 20. X equals 20. Done and done for problem number 9. That's right. So let's just look at a little recap of the problem. It said that if angle A is a right angle and the measurement of A is the quantity 4x plus 10 degrees, then x equals what? We said that x has to be equal to 20. And notice, guys, that we once again did not start off with a diagram. I drew this. All right. I drew this diagram to feed myself with more information. Simone says, no problem. After all, we are witnessing your math greatness. That's right. That's right, Simone. Don't forget the WHITT as you are witnessing. Thank you so much. You guys are awesome. Let's continue with our next problem as we feed you some educational food here to prepare you for the geometry final exam review, aka the second semester final exam for geometry, guys. All right, let's keep it moving with problem number 10 here. It looks like we're given two parallel lines, A and B here, and we also have a transversal line. All right, we have a transversal here, and they are wanting to know the relationships between these lines and angles. Let's go ahead and talk about it here. So for one, they want us to point out what type of angles we're dealing with when we are looking at angle 3 and angle 5. Well, with angle 3 and angle 5, guys, these are called same side interior angles. So the answer to this one, let's go ahead and put it in red here, are going to be same side interior angles. Okay, so that's what belongs in that first blank. That angle 3 and angle 5 are same side interior angles, and when you're dealing with parallel lines, as we are with lines A and B being parallel, because that's what they're telling us by giving us this information here on the right, the top right here, they're saying that A is parallel to line B. So with that scenario and the transversal, we are guaranteed that the same side interior angles would be supplementary. So supplementary, meaning that their sum equals 180 degrees. So these would be supplementary angles as we are looking at problem number 10. From here, we're going to be moving on to problems to angles 4 and 5 now. So let's talk about angles 4 and 5. Angles 4 and 5, guys, are also interior angles because they're within the parallel lines. They're between them, and they're going across the transversal line. Well, these are called alternate interior angles. So with angles 4 and 5, we have alternate interior angles in play. That's what's going on here. Alternate interior angles is what we're dealing with. And when you have alternate interior angles with parallel lines, guys, these angles are congruent. That's exactly what they are, meaning that they have the exact same measurement. Other angles that would have the exact same measurement, guys, are alternate exterior angles, corresponding angles, vertical angles. All of those types of angles, guys, are congruent when you're dealing with a transversal with parallel lines. So keep that in mind as far as that's concerned. But when you're dealing with same side exterior angles, same side interior angles, those angle relationships are that they're supplementary. So therefore, they would equal to 180 degrees when you're dealing with that, as same as linear pairs. Any two angles that make a straight line, that make a straight angle, those are supplementary angles. They add to 180 degrees. Amen. Amen. That's what's going on. All right, let's check out the chat real quick. We have somebody saying that, thank you, sir, for your teachings. I took my final yesterday. God bless you and your family. P.S. Love the intro in the beginning with the southern accent. You got it. I'm out of here in Texas. That's right. I can't help it. With the southern accents. Born and raised in Houston, Texas. H-Town in the house, baby. Don't forget it. All right, so we got Jovan in the house. All right, what's 9 plus 10? 19, Javon. All right, there you go. Let's go ahead and continue on with problem number 11. We got problem number 11 in the house. Javon joining in the chat. So with problem number 11, guys, we're looking at three angles here. All right, and these angles, the sum of them, create a straight angle here. That's exactly what they do. And for every straight angle, every line that you're referring to, the sum of those angles must be 180 degrees. So they want us to find out x as well as the measurement of angle ABD. So where is ABD? ABD would be this angle right here. All right. So they want us to find out what the result of 3x plus 10 would be. But of course, we need to find out the value of x first. And we can do that by setting up an equation. So let's do just that right now. All right, so we're going to have the 3x plus 10, this angle, plus our next angle, which is 4x, plus the third angle, which is 4x minus 50. All three of these angles have a sum of 180 degrees. So with these three angles adding together to give us a value, a sum, a total of 180 degrees, we're going to combine our like terms and get things underway. All right, so here we'll have the 3x plus the 4x plus another 4x. That gives us 11x. Then 10 minus the 50 gives me a negative 40. Let's go ahead and get rid of that plus sign. I got happy, got excited, thought I had a positive coming, but I was wrong. So we have 11x minus 40 here. This must equal 180. There we go. That's right. That's what we have going on right now. Now to isolate the term with the variable, we'll be adding 40 to both sides of the equal sign. Go ahead and get the 40 added to both sides of the equal sign in order to isolate the term with the variable. Yeah, so we end up with 11x equals 220. And you better believe we're going to be dividing both sides by 11 now. Oh, you can't stop me. Oh, you can't stop. No, I understand that you can move off the page, but you can't stop me. Not in real life. Not in real life. You don't have those powers. You don't have those powers. Not today. Not today you don't. So you'll have x equals 22 as a result. That's right. No. 20, guys. I'm tripping. So you got too cocky. That answer is 20. That answer is 20. Sorry about that. So x equals 20 is the first answer that they're looking for. Let's go ahead and red box that before I mess it up again. There we go. We had to protect that right answer before Mr. Witt comes in and tears it up. And then in order to answer the second question, what is the measurement of angle ABD? That's right. Simone says, is it always 180 degrees? Yes, it is always 180 degrees when it comes to a straight angle, because these three angles combined make a line, Simone. It equals 180 degrees every single time. Yep. Every single time, lady. So let's continue on with answering this second part of the problem, which is, what is the measurement of angle ABD? Well, earlier we said, and noticed that we were given this information actually, that the measurement of angle ABD had to be 3x plus 10. So if we were to find 3x plus 10, we'll plug in these values to get 3 times 20 plus 10. Well, that's just 60 plus 10, right? So the answer for angle ABD is going to be 70 degrees. That's what's up. Yeah. I hate that 70. I hate the 0. We're going to fix it. That's a better 70. And now I'm red boxing this because it's the correct answer. There we go. There we go, guys. That's the correct answer for both finding x as well as the measurement of angle ABD. There you go. That's problem number 11, son. I ain't scared of you guys today. All right? No fear. No fear. Not today. Not today. We're going to go on to number 12 now, though. It says, if the diagonals of a rhombus are 20 and 36, then the area is... Okay. We have the formula for the area of a rhombus, guys. And it says that the area is equivalent to 1/2 the first diagonal times the second diagonal. See, I had to write this one down because I had forgot it. I was about to. This problem would have been jacked up if this would not be right here. Because I didn't have it memorized. I knew it, but didn't know it. I wasn't sure, so I had to write it down. There you go. As well should you. If you want to keep these formulas fresh, write them down every time you do them, guys. So let's go ahead and figure this out then. We have 1/2. The first diagonal, I hate the 2. I hate the 2. The 2 needs to be better. It's a better 2 now. Thanks. We'll have the product of 1/2, 20 times 36. This is all you got to do. See, it's a sneaky formula because it's easy if you know it. And if you don't, you're going to get it dead wrong. So that's why you need to know that the formula for the area of a rhombus is going to be half for the product of the diagonal 1 times the diagonal 2. Tony says, you may not believe this, but my son learned this in 3rd grade. I do believe it, Tony, because Noah is off the charts. Tony loves coming in here bragging on his son, Noah, guys. We're going to let him brag because he's a proud papa, like LeVar Ball. All right? So nothing wrong with being a proud pappy, Tony. All right? I'm not hating on that. I'm a proud pappy, too. There you go. Now, due to my laziness, I'll be taking half of 20 first because it's the easier number to deal with to get the number 10 as a result. Now multiplying 10 times 36, we'll have a final answer of 360 units squared for your answer, guys. And I will red box it. Yeah. That's what's going on, guys. Do not forget your units of measurement, guys. Be aware of that when you're dealing with area. Your unit of measurement will be to the second power. When you're dealing with volume, you're dealing with the third power. So anytime they say something like lateral area, surface area, total area, all of that has the units to the second power. And when they're talking about find the volume of something, the units of measurements will be to the third power. So keep that in mind, guys. Another tip for your geometry final. Okay? There you go. Another tip for your geometry final. We're not playing around here. We're not playing around, not today. All right, guys, as a reminder, we want you guys to subscribe to Fort Bend Tutoring, FBT, so you can get more quality content from me, Mr. Witt, and Fort Bend Tutoring, guys. So make sure you're doing that, as well as clicking on the bell icon. And if you're able, please donate. You can donate within the super chat using that $ at the bottom of the chat bar, the chat box there. Also, you can find a donation link within the description box for this video. Amen, amen, guys. Let's keep things moving for the final exam review for geometry. We have problem number 13. Problem number 13, guys. Let's take a look at it. With problem number 13, it says that triangle XYZ is an equilateral triangle. That means that all the side lengths are the same. Let's go ahead and mark this out on the given diagram. We're going to show, using these little hash marks here, that all 3 sides of our equilateral triangle have the exact same length. Another thing you want to know about equilateral triangles is that all the angles must be 60 degrees. Yeah. You have a total of 180 degrees within the triangle, and since all of the side lengths and angles are congruent to one another, all you have to say is 3x equals 180 divided by 3 to get every angle being equal to 60 degrees. In fact, guys, because all the side lengths are the same, because all the side lengths are congruent, because all the side lengths have the exact measurement, then that means that the side length XZ is 8 feet. The side length ZY is also 8 feet. Amen, amen. Seth says, bruh, I took my final today in first hour. I needed this last night, but I think I did okay. Well, there you go, Seth. May God be with you, sir. And if you put in the work, you'll get the result that you deserve. Make sure before you take any exam that you try your best to master the content, because that's what the assessment is requesting of you. How much of this information have you mastered, Seth? That's what they wanted to know. All right. It's not how much you understood, sir. Not how much you understood, but how much you mastered. So as long as you put in the time and effort to master as much of the content that you needed to go over before you took that test, that's what your grade will reflect, sir. All right. And hopefully for you, you put in the time and effort to master as much as possible so you'll pass that test with flying colors, Seth. So I'm rooting for you, sir. I am rooting for you and your results, Seth. Let's get back to this problem here. For the problem, for the side length of zy, guys, we just already figured it out. Zy is 8. That's 8. It's 8. There we go. So this is 8 feet. Okay. We also have already figured out that the measurement for angle Z must be 60 degrees. The only thing we need to answer now is the altitude. And the altitude is simply asking you what is the height of this triangle. How tall is it? So what we'll do, guys, is we're going to go ahead and set up, all right, the altitude, showing it right there. And what this does in the equilateral triangle is it cuts it in half. So let me go ahead and show you guys that I am looking at the following half of the given triangle right now. And I know that this length here is 60 degrees. And because this altitude will cut the angle, it's going to be an angle bisector. It'll cut it in half. This is going to become a 30, 60, 90 triangle. That's what we have here. We have a 30, 60, 90 triangle. I'm trying to get 30 degrees in here, guys, but it's looking kind of ugly. We'll just leave it at that. All right. So I'm dealing with a 30, 60, 90 triangle now, right? Okay. And remember earlier I gave you the ratios for these 30, 60, 90 triangles. And I told you that the ratio for a 30, 60, 90 triangle is that the smallest side will be x. Then the side opposite the 60 degree angle will be x squared root of 3. And that the side opposite the hypotenuse will be 2x in length. And I know for certain that since half of this side has been taken down here below, that we're dealing with a value of 4 for x. Well, if the value of 4 is x, then that means that the 60 degree angle would have to be 4 times the square root of 3. And that the length, obviously, of the 90 degree angle, the hypotenuse would have to be 8, as we have already confirmed in our diagram here. So the altitude, guys, the side length opposite the 60 degree angle, aka the height of this triangle here, has to be 4 times the square root of 3 in length. There you go. And that's going to be in feet, by the way. So we're going to red box our answers. There we go. 8 feet, 60 degrees, as well as an altitude of 4 times the square root of 3 feet. Yeah, that's problem number 13. Go ahead and let all of that marinate for a little bit, because that was a lot to digest at once, I know. But hopefully this is just a refresher that you've already worked on mastering this before, and it may have been a while. You just need to be reminded of all of this. That's all. You just need to be reminded. That was problem number 13. I'm changing the ink to black again. I'm moving on to problem number 14. You're coming with me. Thank you. We have problem number 14, guys. With problem number 14, we want to find the area of the parallelogram. That's exactly what we want to do. And finding the area of this parallelogram, we need to keep in mind that the area of a parallelogram is the base times the height. It is the base times the height. Thank you. Base. Thank you. Of the parallelogram. So we know the length of the base is 20 here, but we don't know the height. So once again, we'll be defining a triangle here, and more specifically a right triangle, to assist us in solving for the height, the altitude of this shape. So it's very similar to the previous problem in how we did this. We're also looking at, by coincidence, another 30, 60, 90 triangle, guys. We have 60 degrees down here. We got 30 degrees here. We have 90 degrees here. I know that this is going to be a 30-degree angle right here because This is a 90-degree angle down here, and they told us that this was 6 degrees. So 60 plus the 90 is 150. 150 from 180, which is the sum of the interior angles of a triangle, it left us with 30 degrees. So we are now, once again, looking at this 30, 60, 90 relationship once again, ladies and gentlemen. That's exactly what we're doing. So Tony says the area equals the base times height. Yes, base times height, sir, but not times height squared. And the h in there is the height of the parallelogram. That's what it's referring to, Tony. All right. So let's go ahead and figure this out. We want the value for the side length that's opposite the 6-degree angle. We know that 2x currently equals 12. So to solve for x, you just divide both sides by 2 to find out that x equals 6. So if x equals 6, then the altitude is 6 times the square root of 3 because 2x is 12. So we're looking at 6 times the square root of 3 as the height of our parallelogram, guys. And going back to our formula for the area of a parallelogram, we have the base, which has a length of 20, times our height that we just solved for, which is 6 times the square root of 3, to give us a result of 120 times the square root of 3 units squared, guys. And this is the answer for problem number 14. Yeah, it is. There we go. That's how that's done. Using our special right triangles. Amen, amen. Yeah. What you guys think? You got any questions? Talk to me. Talk to me about that. We started out with our parallelogram. We were shown that we had an angle of 60 degrees here. We showed where our altitude would be. That created a right triangle. With this right triangle, it made us a 30, 60, 90 right triangle. And with our known relationship between those angles and side lengths, we were able to deduce that our value for the height was going to be 6 times the square root of 3. And using that formula of area equals the base times height, we ended up with 120 times the square root of 3 units squared. All right, good deal. So we have it. So Tony and Noah are asking their off the chart questions again because this is dealing with geometry today, Noah. All right, so you're gonna have to have your dad help you out with that one. We have problem number 15. Problem number 15, guys. We have an example where we can show the remote angle, the remote exterior angle rule. There we go. All right. What's going on, Simone? Simone says the square root situation in the problem is new to me. Wasn't taught that. Do you have videos covering that? Not specifically, Simone. Not specifically. So good thing that you were chiming in today so you could be exposed to that. All right. So I will have some in the future, but I don't have any dedicated ones that cover those specifically as of yet. But they're on the way. Thanks for asking, Simone. All right, good deal. So there's a lot of videos that I have to put in some work in, Simone, to say the least. All right, so you don't have to feel sorry about me not having content to provide for you guys. I got a ton of it coming. Working on something right now that's going to be very, very good for those people in calculus coming out pretty soon. All right, so for problem number 15, we got the remote angle rule going on, the exterior angle rule. And the bottom line is that the sum of these two angles, guys, the exterior angle rule, that is the sum of these remote angles, the x and the 80 degrees here, it must be equivalent to the 150 degrees. That's right. And Seth says, am I going to go over any trig functions? I may have some trig functions today. If not, you'll probably see some in part 2 of this review, Seth. And if you're going to be really thirsty for those, then you can already check out a video or two that I have on the topic in our trigonometry playlist. So check out our trigonometry playlist, especially the video that's called Finding the 6 Trigonometric Function Values. Check out that video, sir, because I go over that extensively in that video. So let's go ahead and set up this equation here. We'll say that 150, I don't like that color. Let's fix the color here, guys. This problem will be 150 equals to x plus 80. So once again, the way this works is, what's going on, Angry Hermit? The way this works is the two angles here within the triangle must be equal to the value on the exterior, this exterior angle here. There you go. It has to be equal to that 150 degrees. So in solving for this, we're going to be subtracting 80 to both sides. That's exactly what we'll do. And we'll end up with 70 degrees for our value of x, and done. Red. Box it. Once again, part of the benefit of geometry is that once you know the rules, the actual process for solving the problems are not that difficult. What's challenging is memorizing, being aware, knowing all the different rules that are given to you in the course. Because they just don't stop, do they? Every day they just dump more and more properties and formulas on you, right? So I feel your pain, bruh. But that is how you solve that problem. Thank you, Angry Hermit, with the link to the finding the 6 trigonometric values when you're dealing with SOHCAHTOA. All right. Seth, did you know that SOHCAHTOA could also be memorized as some old hippie taught another hippie? Oh, caught it. Oh, no. Hold on. You're missing something up, Seth. It's not SOHCAHTOA. It's SOHCAHTOA. It's a CAH for that middle part. CAH. All right. It's SOHCAHTOA. And it's going to stand for some old hippie caught another hippie tripping on acid. There you go. That's a free one, Seth. Problem number 16. We have given y is the midpoint of side length xz and wv. Prove that angle w is congruent to angle v. Let's check that out, guys. Let's go ahead and start by filling in this diagram. Well, for one, guys, according to the vertical angle rule, that anytime you have two lines intersecting, that the opposite angles must be congruent to one another. I know that this angle has to be congruent to this angle here. Thanks, Simone. Good deal. Thanks for that shout out. I try to keep it entertaining, guys. All right. Angry Hermit says geometry is fun. You just have to look at it from the right angle. Angry Hermit, I am sending one big hug your way right now. I know you're a hermit and you're not going to let anybody in, but I'm going to get in and get that hug. Okay, so because of the vertical angle rules, guys, these opposite angles must be congruent to one another. Also, because point y rather is the midpoint of xz and yz, I can show that this half has to be the same as that half, and that this half has to be the same as that half. Now that we have this, guys, we can go ahead and prove that these two triangles are congruent to one another using the property side angle side. All right, what's going on, Simone? You don't have to try when it comes naturally. Appreciate that. So here's the deal. We have just proven that these two triangles are congruent to one another using the side angle side property, which says that if they have the two sides that have the same length with the captured angle in between being the same measurement, then the entire triangle is the same as the other triangle. And that's what we've proven with the side angle side property here, guys. Because of that, we can use something called CPTCT. All right, let me say PC. Is that right? Congruent parts of congruent triangles. CPCTC. I always mess this up. Congruent parts of congruent triangles are congruent. All right, let's figure this out. I think it is congruent parts of congruent triangles are congruent. I think this is it. All right, there you go. So because we were able to prove that these two triangles are congruent, guys, we can use CPCTC, which stands for congruent parts of congruent triangles are congruent. There you go. Therefore, we can state that angle W is congruent to angle V now, because we were already able to prove that triangle XYW is congruent to triangle VYZ. There you go. XYW is congruent to VYZ. There you go. All right. Good stuff. Seth says that is correct. That I said it correctly. Fantastic. All right. So the first step, guys, is to use the given information, all right, to verify that by definition of the midpoint that the halves where this value with this point y cuts these two lines in half are congruent to one another, and because of the vertical angle rule that states that angle XYW must be congruent to angle VYZ, that once we were able to identify that, we could then state using the property side angle side for triangles that these two triangles are congruent to one another. And then because of the congruent parts of congruent triangles are congruent, that means that angle W, which is right here, guys, has to be congruent to angle V. Done and done. All right, and we got a nice little cosine, a nice big cosine, no pun intended, Seth, from Seth. All right. See, I said cosine, guys, but that sounds like cosine from Trick. I am having way too much fun with this today, guys. I have way too much fun with this, and I couldn't even foresee it. Nope, didn't know that was coming. That's all on the fly because you guys are fresh. Funky fresh. Thank you. Problem number 17. Let's keep it moving. With problem number 17, it says list the sides from largest to smallest. List the sides from largest to smallest. That's what we want to do. But the first thing we need to do, guys, is identify all the values of the interior angles of this triangle. We already know that the sum of the interior angles of a triangle must equal to 180 degrees. All the time, Simone, 180 degrees. That's right. Sasha says, so for the SAT, should we know the formulas for most shapes? Absolutely, Sasha. Do not rely on any formulas that they may give you. All right, you want to go into the SAT knowing as many formulas as possible because there's no guarantee that they're going to give you the formulas for that stuff. All right, so yeah, you want to be familiar with as many geometric formulas as possible because it will help you solve the problems much quicker. All right, absolutely, for the SAT or the ACT for that matter as well. All right, you definitely want to go into the SAT knowing as many of the geometric formulas as possible. Do yourself a favor. All right, problem number 17, guys. It says to list the sides from largest to smallest. Okay, so let's go ahead and start by labeling this first. We'll say that this is side C is opposite angle C. This is going to be side A opposite angle A, side B opposite angle B. All right, and what we're going to do with this is we're going to solve for angle C by adding 70 and 80 together and subtracting from 180. So we'll have 70 degrees plus 80 degrees. That gives us 150 degrees. And then 150 degrees from 180 degrees leaves us with 30 degrees. So angle C must be 30 degrees. Well, the way it works, ladies and gentlemen, is the side lengths will be in order from least to greatest based on the sides, based on the measurement of their angles. All right, that's opposite to them. So because angle C has the smallest angle measurement, then it will capture the smallest side length is the way it's going to work. So from largest to smallest, guys, since we have 80, 70, and 30, we go with those side lengths. So that means that side BC is going to be smallest. The next in line is going to be side AC. And then finally, we will have side BA. Well, let's go with AB. Okay, we'll put an alphabetical order there. And it's based on the fact that each of those side lengths, the angle that captures it, okay, will be reflective of the lengths of the sides. All right, so the largest angle captures the largest side length. The smallest angle captures the smallest side length. And there you go. And so the side length in between, the angle length in between, the angle measurement in between captures the side length in between those two extremes. All right. I think I need to say that one more time. Bottom line is side C was the smallest because it had the smallest angle. Side A was the largest, had the largest angle. Done. All right. Red, boxing it. I think I just flubbed all of that. That just sounded real weird coming out of my mouth. But anyway, I think you guys got it. Smallest to least. You just go in order of the angles and the side lengths that's opposite them. And you're good to go. That's problem number 17. All right. Doing it live, guys. Okay. It's not rehearsed. So there you go. Can't all be perfect like you. Problem number 18. we have side length OB. Okay, it's going to be 8. There you go. Has a length of 8. The measurement of AOB is 90 degrees. Let's go ahead and check that out. They want us to find the length of AB. They want to find out this length right here. Well, guys, because we are dealing with radii, okay, OB and OA are radii. O is the center of the circle. We are dealing with a 45, 45, 90 degree triangle here. Because OB has a length of 8. OA must also have a length of 8. And this is going to be what you should recognize as a 45, 45, 90 degree triangle. And the way the relationship for a 45, 45, 90 degree triangle works is that the ratio is 1, 1, square root of 2. Or with variables, you'll say that if you know the value of x, that will be the same value. And the side opposite the 90 degree angle will be x times the square root of 2. And in our case, our value of x is 8. So if that's 8, the side length of opposite the 90 degree angle is going to be 8 times the square root of 2. So I think we just solved that, guys. Side AB, it has to be 8 times the square root of 2. That's a special triangle, guys. So just like we referred earlier to our 30, 60, 90 triangles, this is going to be the relationship for our 45, 45, 90 triangles. And you better have that down for not only the SAT, but also for your geometry exams. All right. Those 30, 60, 90 triangles are going to save your life. All right. As well as the 45, 45, 90 triangles. And Seth, that's also going to be important for your trig classes. Those trig relationships, they rely on those relationships heavily. Those special right triangle relationships, the 30, 60, 90, as well as the 45, 45, 90. Better know it, all right, because that's what you'll be tested on. Done and done, son. That was part number 18, guys. And we're moving on with part 1 of the geometry final exam review. So, just another reminder, guys, that if you want one-on-one tutorials from me, Mr. Witt, if you want to get all this attention for you, that's right, I'm talking to you right now. Go ahead and set up a paid online tutorial today at tutormemath.net. That's right. There you go. That's what's up. Holla at your boy, and I'll holla back. Okay? Let's move on to our next problem. Problem number 19 is underway. There you go. It says, find the scale factor of two rectangles if the perimeters are 36 centimeters and the other is 48 centimeters respectively. Well, because this is going to be on a 1-to-1 ratio as far as the units of measurements are concerned, guys, all you have to do is say, I had 36 centimeters and I multiplied it times something to get 48 centimeters. So in other words, in order to find out this scale factor, just divide both sides by 36 and simplify. That's it. That's all you got to do. See, we can reduce both the 48 and the 36 by 12. Let's reduce both of this by 12 to get this scale factor. So this will give you 4/3, right? Done. It's over. Angry Hermit. What's up, Angry Hermit? What happened to you? Why the gorilla face? What's up with that? Is that Harambe? What are you doing with that gorilla face right there? You trying to get some sympathy from Harambe? All right, tell me what's up with that, Angry Hermit. We have problem number 19, guys. It is in a red box. This is the scale factor, and that's how you find it. You just divide and simplify. I'm moving on. I am so moving on to problem number 20, guys. With problem number 20, it says, all right, Shailene over there with the laughter. Angry Hermit says, I don't know, but I had a dream this morning that a gorilla came to my house. What's the gorilla's name, Mr. Witt, is the question. All right. So with problem number 20, okay, and if it was, he better have given you a hug because I promised you one earlier. We have M is the midpoint of the segment CF for the points C, which is 3, 4, and F, which is 9, 8. These are ordered pairs, guys, for these 2 points. That's what's going on. And find the length of MF. That's what we want to do. Yeah. All right. So let's go ahead and set up a diagram for this just to get everybody on point together. There we go. Let's go ahead and hook this up. All right. And let's say that we have point C. We got point F here. And we have the midpoint M in the house. Okay, but this is actually mostly on a like a Cartesian plane type situation. So to be honest, all right, I mean if we really wanted to show off, let's do this. Okay, if we really wanted to show off here, let's get this going. All right, we're gonna do it right. Okay, we're gonna do it right up in here. We'll do it right, and we'll say that we have a point C at 3, 4. So 3, 4 is right here. All right, not that you have to have a diagram for this, guys, but just because I'm going to show off for a second and get my C popping at 3, 4. Got my F popping at 9, 8. 9, 8 is right here. There we go. There's 8. Hey, fix that. There we go. We got F right there. Bam. And we know that M is in the middle somewhere. We're going to go ahead and figure this out. All right. So that being the case, in order to find out the midpoint formula is going to be as follows. Let me hook you up with that midpoint. So the midpoint formula is going to be x1 plus x2 divided by 2. And then we'll have y1 plus y2 divided by 2. There you go. There's a formula for the midpoint. And you're going to label your points first. Label your points first. So for C, we're labeling that as x1, y1. For F, we're labeling it as x2, y2. And then we're going to plug in these values, all right? So for the first value, that x1 value, we're going to have 3 plus 9 divided by 2. Then, to get that y value of the midpoint, you're going to have 4 plus 8 divided by 2. That's exactly what we have. And simplifying this, you'll find out that the point, all right, the point for MF is going to be at 12 over 2. 12 over 2. That's going to be 6, 6. All right, it's going to be 6, 6. So our point is at 6, 6. However, they want us to go a step further, guys, and they want us to find out the distance. So I guess we could have just found out the distance between those 2 points and then divided by 2. But then I wouldn't have had the opportunity to show you how to find the midpoint. All right. So Angry Herman says, what's the point? The point is the point of finding the midpoint first if you wanted to have that value. But they also want to know the distance between those. All right. So finding the distance of the midpoint, which is at 6, 6, by the way. Let's look at this. 6, 6. Yeah, it's right here. This is M. That's the midpoint at 6, 6. They want to find out the distance between those. So we could do that using the Pythagorean theorem. Let's do that, guys. Should we do that? Let's do that. We'll find it that way. So using the Pythagorean theorem here, we're going to hook this up. I know that, and I'm setting it up right here. Boom. Okay. I know that the height of this would be 2. I know that the distance between them is going to be 3. There you go. And we can use the Pythagorean theorem to solve for this. So let's go ahead and hook that up right there. So we'll say that a squared plus b squared equals c squared. See, your c value is going to be the distance between your point MF. Hey, MF is the other way. Stupid. Let me fix this, guys. We don't want to know that value. It's actually going to be the same thing, though. It's going to be MF. There we go. So we still have a height of 2. We still have a distance of 3. So that doesn't change any. All right. So plugging this in, then we'll have 3 and 2. So that's going to be 3 squared plus 2 squared equals c squared, like so. All right. And then we'll have 9 plus 4 equals to c squared. So then 13 equals c squared. And so now you'll have the square root of 13 as your result. That's the distance for MF. So you get a 2 for 1 on this problem, guys. Not only did I show you a method of finding the distance between those 2 points using the Pythagorean theorem, I also showed you how to find out the exact point of the midpoint using the midpoint formula. Yeah. So you got a twofer in that one. Oh, yeah. There you go. You got a twofer. What do you think? I think that was pretty good. I think that was informative. I think you can use that for several things. Let's move on then. Next problem coming up. We got problem number 21, guys. We got problem number 21. It says to find the circumference of the circle in terms of pi. Well, the circumference of this circle could be said to be 2 pi r. Let's not forget that the circumference is also the diameter times pi, but they're giving us the radius. All right. Shub Patel says, do you do vids of Math 2? What is Math 2, Shub? I don't know what Math 2 is. Math 2, is that like Algebra 2? Is that like, algebra? Pre-calculus? What does Math 2 consist of, Patel? Let me know that. But you can find most foundational math subjects on our YouTube channel for Ben Tutoring Ship. So they'll have playlists for them. Because all we do is math on Forbidden Tutoring. I mean, we know what we specialize in. It's math. There you go. So look on our. It was either specify what Math 2 is, Mr. Patel, and then I can let you know. Otherwise, you can check out our YouTube channel where we go over mathematics, geometry, algebra, pre-calculus, calculus. You know what I'm saying? Check it out. All right. So let's go ahead and solve for this problem. They gave us the radius, guys. So we'll have 2 pi. Our radius length is 39 inches. And then multiplying this out and leaving it in terms of pi, you'll end up with 78 pi as a result. And the unit of measurement remains the first power when you're dealing with the circumference, guys. The distance around that circle is 78 pi inches. And this is the answer for problem number 21. That's it. That's all you gotta do for problem number 21. Done and done, son. All right. So that's 21. And moving on to our next problem, which is problem number 22. There you go. Angry Hermit went ahead and hooked you up with that intermediate algebra playlist and says that it probably has at least some of what you need. I absolutely agree with that, Angry Hermit. But we'll see what Mr. Patel replies, and we'll see what that's all about. But you guys should recognize in problem number 22, this shape that we're dealing with, this quadrilateral that they have before us, is a trapezoid. And they want us to find the area of this trapezoid. And the formula for the area of a trapezoid, guys, is area equals 1/2 the height times the sum of the bases. And when we're referring to the bases, guys, we're talking about the parallel side lengths. In this case, it would be, let me go ahead and circle those parallel side lengths. The 8 inches and the 12 inches are the base 1 and base 2 that we're referring to. Amen, amen. So that means that we need to identify the height. And the height, guys, needs to be the perpendicular segment between our parallel sides, which in this case is going to be this side length over here, the 7 inches. It's going to be the height of our trapezoid. Yeah. So it looks like we have everything we need to solve this. So it's going to be 1/2. Our height is 7. Our base 1 is going to be 8. And you can say that either of these is base 1, base 2. It doesn't matter, just as long as you add them together, so you'll be all right. You don't have to be bogged down by which one is base 1 and which one is base 2. It's up to you. Just make sure that you're finding the sum of the parallel side lengths when you're doing this formula for the area of a trapezoid, okay? Then base 2 is 12. And now the order of operations. Go ahead and start inside those parentheses. 8 plus 12 is 20, guys. And because I'm getting my lazy on, I'm going to take half of 20 because it's easier to find. So this is going to be 7 times 10. So my answer here is 70 inches squared. Once again, your unit of measurement, guys, must be to the second power because you're dealing with the area. And area is always to the second power. All right? So keep that in mind. Your unit of measurement must be to the second power when you're doing this. Okay? So that's problem number 22, as we found the area of the trapezoid. Yes. Let's continue on to our next problem, guys. Problem number 23 is in your face. It says, which equation represents a circle whose center is 3, -2? Seth says, could you also write the formula as area equals to the height times base 1? Let me see, Seth. You can write it this way. Okay. You can write it as the height times the sum of the bases, base 1, base 2, but everything has to be over 2, okay? Not just that base 1 plus base 2. Well, you know what? Yeah, that'll work too, though. Would that work too? Yeah. Your method would work too as well, Seth. That's correct, because you could write it that way. You could write it as the height divided by 2 times the sum of the bases. Yeah, any of these permutations would work. So your method was this. Yeah, that'll work as well. Yeah. Seth, you were correct. You were correct, Seth. That version works. And speaking of formulas, guys, the formula that we'll be referring to for this problem in number 23, as far as the equation of a circle is concerned, we'll be referring to x minus h squared plus y minus k squared equals r squared, where the center of the circle is going to be hk. Okay, so the center that they're referring to, that they're requesting, is HK. Let's just put that right there in the middle of the logo. All right, there we go. So there is a video that covers the equation, the center radius form of a circle. All right, so Angry Hermit could please post that link. That'd be helpful. And we're going to be utilizing this formula here to identify which form we need to refer to. Notice that all of our values on the right side are the same. So we just need to make sure that we're aligning correctly with the left side of the equal sign here. And the left side of the equal sign, guys, if we're saying that our center is 3, -2, that means that our h value has to be 3 and that our k value has to be -2. But notice that our formula calls for the opposite of those values. Thanks, Angry Hermit. Appreciate that. So it's calling for the opposite of those values. So the opposite of 3 is -3. So we need to have an x minus 3 going on. So that's going to eliminate choice C and D off the bat. Okay, that can't be the answer because our h value is 3. So we needed to be the opposite of that value. So we needed to have h minus 3, which is going to also eliminate B. So before we can even get started, guys, it's already done. It has to be choice A. Choice A has to be the answer because it's the only solution that has what we need at the beginning, which is h minus 3 squared. We have to have the x value and the opposite of our h value, which in this case is +3. So the opposite of +3 is -3, which is why A is the answer. All right, that's it. We can't do anything else with that. I mean, that's the answer. I mean, go ahead and move on to the next problem. Stop playing around. Stop playing, guys. Problem number 24. It says to find the value of x. In finding the value of x, guys, we're looking at another right triangle. And they have given us 2 out of the 3 sides of this right triangle, which means we will be using the Pythagorean theorem, the a squared plus b squared equals c squared formula. How many times are they going to throw this up in our face today? Right? So let's go ahead and show off that we know how to do this. If we say that our a value is 9 and that our b value is c, then our x has to be the b value. Why is this? Because the hypotenuse always must be, it has to be every single time, guys. The c value has to be the hypotenuse. It has to be the side opposite the 90-degree angle. It has to be the longest side of the triangle, no matter what, when using the Pythagorean theorem. Don't ever label C as anything other than the hypotenuse of the right triangle. It must be done. So that being the case, let's go ahead and plug in these values then. We'll say that our A is 9, right? So we got 9 squared plus our B value is X, so that's X squared, equals to our C value of 15. So that's 15 squared. And then simplifying this, knowing that 9 squared is 81, plus X squared, which equals to 15 squared, which is 225. We'll then subtract 81 to both sides, just like this, to end up with x squared equals 144, guys. And then as we take the square root of both sides, you'll end up taking the square root of 144, which means that your answer for x is 12, because the square root of 144 is 12, as 144 is a perfect square. And we will red box it. Just like that, guys. Just like that. And ladies and gentlemen, once again, just wanted to remind you guys to subscribe to Fort Bend Tutoring. This is going to conclude part 1 of the geometry end of course second semester final exam review from Fort Bend Tutoring and me, Mr. Witt. As always, I appreciate you guys chiming in with me today. We had Angry Hermit up in the house. We had Seth in the house. We had Mr. Patel in the house and others. That's right, chiming in. We had Fabiola. We had Kaylee. We had Sasha and Tony and Noah and Javon and King Valdez and Raul chiming in today. Charmaine was in the house. Simone was in the house. And ladies and gentlemen, please rate, comment, and subscribe. And if you're able, please donate, as that helps us bring you more free content from me, Mr. Witt, and Fort Bend Tutoring. Peace, guys. Take care.
Thanks for watching. We appreciate you hanging out with Fort Bend Tutoring. Like the video, comment, and subscribe. Hit up our website, tutoringmath.net, and set up a private tutorial with me and FBT. Oh yeah, baby.